going to do it. Okay? Equations of lines. Now we're going to be doing a lot of different things, but they all follow the same process. If we follow close, we're going to miss something. Good. Okay? So, equations of lines. The first type of equation we looked at was an equation in standard form. Okay? Standard form was A x plus b y equals c. That's our standard form. That's the very first one we looked at. Okay? Next, we went into slope intercept form. Y equals mx plus b. Okay? And that's the one that we're most familiar with, the one we're most comfortable with, slope intercept. Like that's like the bread and butter of linear equations, the slope intercept form. Okay? That's the king of all linear equations, slope intercept form. Okay? Which is where we started. Alright, or which is what we use most of the time. Now all these equations have different uses depending on what we need or what information we're having. Okay? Slope intercept form is great when we have the slope and the intercept, or we need the slope and the intercept, the y-intercept. So we started with equations in slope intercept form and said, okay, well, what is the slope, what is the y-intercept? Finding that information. Now we're going to be given that information and we need to write the equation. Okay? So it's just a little backwards. Okay? But same process. We're looking at our slope intercept form of y equals mx plus b. Which of those two letters am I going to change with the information provided? Yeah. So m and b are going to be replaced. X and y aren't one specific number. They're all the numbers on the line. But m and b are going to be replaced with slope and with the y value of the intercept. So we get y equals 2/3 x minus 5. And that's it. We're done. We did it. Woo! Take the points, the information, write it in a slope intercept form. We've got the equation of our line now. All right. Nice and easy to start. Questions, comments, concerns? This notation will be the primary notation if you are graphing, usually. Also, if you're using your graphing calculator, this is a notation that you need to have. Slope intercept, okay? Because that's what your calculator takes it as its input, is a slope intercept form. Okay? So graphing from slope intercept form. All right? We're given the point, we're given a slope. So instead of finding a bunch of points and plotting them, we only need to plot one point, our starting point, our y-intercept, and then use the slope to get the next ones. So, looking at y equals 1/4 x minus 3. What's my y-intercept? -3. 0, -3. It's a point. Write it as a point. 0, -3. So I can plot that point. I've got it right here. 0, -3. Okay, there's my y-intercept. What's my slope? Good. My slope is 1/4, and we interpret that as a movement 1 unit up from our y-intercept, and then 4 units to the right. 1 unit up, 4 units to the right. So if I go up 1, I go 1, 2, 3, 4, boom, there's my second point. I didn't have to do any calculations, it's just coming. It's just counting. So I start at my y-intercept, and I apply my slope, and I rise up 1 unit, and then I go to the right 4 units after I start at my y-intercept. Now, I usually like to have 3 points. So instead of continuing to go this way up and to the right, what would I do if I wanted to go backwards? Down 1, left 4. Okay, I would do the opposite movement. Down 1, left 4. So instead of going up 1, right 4, I would go down 1, 1, 2, 3, 4 to the left, and I still have that straight line. I still have that positive slope that continues. Even if I go backwards, I still get that same slope, rising up and to the right. Remember, this is a positive slope. So it's going to go up and to the right. So I need to make sure that my graph matches that expectation of that slope. It goes up and to the right, my graph better go up and to the right. If it doesn't, I need to reevaluate where those points ended up or where your intercept was. Okay, up and to the right. Okay? Questions on our slope intercept. So, useful if we have it in slope intercept forms. Our bread and butter, it's our most common. But I'm not always given my y-intercept. Sometimes I'm given just two random points. Sometimes I'm given the slope. So we need something else for those situations. Okay? This is where point slope form comes in. Okay? Point slope form. It's very, very similar to slope intercept form, but it works for any point, not just the y-intercept. This is something that you need to memorize. Memorize your point slope form. And here's my advice for memorizing. Okay? Fun facts, about your brain. If you write something out and say it out loud while you're writing it, you increase your chances of memorizing it or remembering it by about 70%. That's a lot. Okay? So every single time that you have a question that you need to do on a homework, on a practice, in the notes, you're going to see me in the notes here. Write out the formula first before you fill anything in. Write it out every single time. So you should be writing out point slope form, that equation, 10 or more times on an assignment. However many times you need it, write it out. If you need it twice, write it out. 3 times, write it out. Every single time, write it out. And that's going to improve your chances of remembering that formula. I'm not giving it to you. You need to know it. Just like you know slope intercept form. You know y equals mx plus b. Okay? You know that. But you also need to know point slope form. And we're also going to talk about standard form. You need to know standard form. Because a lot of the stuff that we're doing in this section, the process overall is very similar. There's small tweaks about how we get our slope. There's small tweaks about what point we're using. The big difference comes in how do they want the answer to look. Because they'll say, write your answer in standard form. Write your answer in point slope form. Write your answer in slope intercept form. Write your answer in function notation. So it all comes down to those differences at the end of how the equation is supposed to look. So making sure that you're aware of those. So with slope, point slope form, just like with slope intercept form, y and x represent all the points on our line. So we're not changing those. What we're filling in with our formula is y1, x1, and slope. And we get y1 and x1 from the point that's given. Notice how it's not the y-intercept. Okay? It's another point on the line. So we use our point slope form. So we start with y, no change there, minus. What's the y value of this point? 12. So y minus negative 12 equals, I have a slope of negative 2, that's given here, slope of negative 2, and then x minus negative 11. Alright? So now let's clean it up a little bit because we got some excess stuff. What happens when I subtract a negative number? Turns into a positive. So I have y plus 12 equals negative 2, and the same thing's going to happen here and turn it into plus 11. That's point slope form. It is. I just didn't write it. That's our point slope form. Okay? Notice I haven't distributed that negative 2. It's still on the outside. That's point slope form. Okay? I'm not distributing that negative 2. Alright? But it doesn't want my equation in point slope form. It wants it in slope intercept form. So what is the big thing about slope intercept form? What does it look like? I get y equals mx plus b. The important thing to note about that is y is by itself. Get y by itself. So now we can distribute, so we can clean that up. Okay? Because we want to end up in y equals mx plus b, but again, y is by itself. So we distribute y plus 12, negative 2x minus 22. And then to get y by itself, what do? Subtract 12 on both sides. So when I subtract 12, it'll let me draw the subtraction sign. There we go. Y equals negative 2x minus 34. There's my slope-intercept form. So use point-slope form, fill in the numbers, and then rewrite the equation. And we're going to be doing a lot of that. Fill in the numbers, rewrite the equation. Fill in the numbers, rewrite the equation. Fill in the numbers, rewrite the equation. Sometimes we have to find slope first, then fill in the numbers, then rewrite the equation. So find the equation of the line that passes through -4, 0, and 6, -1. Okay? Write the equation in standard form. Do I know my slope? No, they don't give me my slope. They give me 2 points. Can I find my slope given 2 points? What do I have to use? There you go. Our slope equation. Again, another thing that you have to memorize. Sorry, you got to memorize so many things. Sorry, but I'm not really that sorry. Equation for slope. So step 1, find slope. Find slope. If it's given to you, great. You can skip step 1. Otherwise, you're going to find slope. Okay. Doesn't matter which one you use for y1 or point 1 and point 2. I'm just picking some. All right. So we get -1 minus 0 and 6 minus -4. We get -1 over 10. So that's my slope. All right. So my 2 options for equations given slope and some points is either slope-intercept form or point-slope form. In order to use slope-intercept, I have to have the y-intercept. Do I have the y-intercept? No, I had the x-intercept. Point 1, that's my x-intercept, but it's not my y-intercept. Y-intercept is 0, comma, a number. So I can't use slope-intercept form, so I have to use point-slope form. Okay, so we're going to write our equation. Point-slope form, I'm going to write it out, and I'm going to say it because it's going to help me remember it. Y minus y1 equals m times x minus x1. It's going to help me remember it. All right? So now I'm going to fill in my information. I just need to use one of those points. I'm not going to use both of them. I use the slope and a point. I'm going to use point 1, mostly because that 0 makes my life a whole lot easier. Okay? You'll still get the same answer no matter which point you use. You can use either one, but you're only using one of them, not both. Do not use both. One only. Y doesn't change. What's my y1? 0. What's my slope? Yeah, we do. We just found it.
Oh, -110.
There you go. Okay? X stays alone. Leave it alone. What's x1? -4. When I subtract a -4, it becomes plus. I'm just saving myself a step there. Okay? +4. So I end up with x plus 4. And then y minus 0 is just y. So that stays the same. Okay? Well, so now I'm in y-intercept. Well, almost in y-intercept form. Pretty close. Okay? But I need to get in standard form. Okay? So looking back, standard form versus slope-intercept form, what's some of the big noticeable differences between these 2 equations? Of how they're set up, how the variables are set up, and the information that we're given. Y has a coefficient, okay? In slope-intercept form, y does not have a coefficient. Y is just y. What else? Another big difference. Has a coefficient. X is first. One more thing. One more big thing. No, this C and B are not going to be the same. C is just a constant. It's not going to be the y-intercept. They're in the same side. Not the wrong place, a different place. In standard form, y has a coefficient that doesn't have to be 1. And they're on the same side of the equation. So that's a noticeable difference for standard form. So we're going to take this equation, and we want to get x and y together, constant on the other side. All right? So we'll do distributive property. Y equals -1/10 x minus 4/10. Okay, minus 4/10. And I want x and y to be together, and then I want my constant by itself. So I need to move this term to the other side. So how do I move that term to the other side?
Add it.
This term, because I want x, yeah, we're going to add it. Because I want x and y on the same side, so I need to move x over with the y. Okay, so I'm going to add, so I get 1/10 x plus y equals negative 4/10. Okay, getting closer. Last thing is, with standard form, we don't like fractions. So how do I get rid of my fractions? I'm not going to do decimals. I want integer numbers. No. By 10. Why 10? It's my least common denominator. I'm not going to flip them. I'm going to multiply by 10. I want to multiply everything by the least common denominator. Because that's going to cancel out those denominators. It's going to cancel out those denominators of 10. So what's 10 times 1/10? 10 over 10, which is 1. So I get 1x. 10 times y, 10y. What's 10 times 4/10? Negative 4. There's my standard form. X and y together, constant on the other side, and get rid of your fractions. Multiply by your least common denominator, get rid of your fractions, and then we're good to go. There's standard form. Standard form is most useful for our intercepts, finding x and y intercepts. Okay, that's where standard form comes in handy. Because I want you to remember, think about, what do I do to find my x-intercept? What do I do to find the x-intercept of a linear equation? What do I do to find the x-intercept of a linear equation? Set when y equals 0, right? So if I have y equals 0, what happens to this term? It goes away. 10 times 0 is 0. It goes away. There's my x-intercept, negative 4, 0. Okay? Same thing for finding x for y-intercept. We set x equal to 0. It makes that term go away. And then I can solve for y to get my y-intercept. So standard form is useful for finding your intercepts, while point slope form and slope intercept form are useful more for graphing or for analyzing slope given a point or the y-intercept. So they have different uses depending on what we're given. All right, same process, but now our answer is going to look different. It wants function notation. Anyone remember what function notation looks like? F of x. We replace y with f of x. So function notation is y equals f of x. All right? So I'm given 2 points. What's the first thing you need to find? Slope. I need slope. If I don't have slope, I need slope. Pretty much almost all the equations need slope. All right? Because we're either using point slope form or slope intercept form, and I need slope. Okay? And it doesn't matter which one you use. Okay? So 3 over negative 4 and 5 over 2. There's my slope. 4. Okay? I got slope. Now what? I don't know my y-intercept, so what do I have to use instead? I have my slope. I have some points. Point slope form. I have my slope. I have some points. Point slope form. So that's step 1. Step 2. Y minus y1 equals m times x minus x1. What am I going to do with y? Okay, so do I do anything with the y or do I leave it alone? Leave it alone. What's y1? Okay. What's m? What do I do with x? What's x1? Okay, so I used point 1 for both of those. Okay, you got to use the same point. Use 0.1 for both of those. You can do it with 0.2. We get the same answer once we move everything around. Okay, we'll get the same answer. All right. So I need to get it in function notation. I need to get y equals f of x, so which means I need to get y by itself. What form gives me y by itself? Y equals mx plus b, slope intercept form. So let's clean this up. I will. I'm going to do distributive property first. Four thirds, so 13 thirds. Alright. So I'm in slope intercept form. Yeah. Go for it. Mixed numbers? I don't like mixed numbers. They're only useful in application problems. So unless I'm doing an application that ends up with fractions, I don't ever use mixed numbers. I always do a proper fraction. Okay? So function notation, I replace y with f of x. So what am I going to do to finish this equation? Replace y with f of x. Same steps, different output. So you have to look for what the question wants. So there's some vocab there you have to make note of. Function notation, standard form, point slope form, slope intercept form. You need to be aware of what the question is asking for, which will require you to read the question, which is the eternal struggle of high school students. You never want to read the question. Okay? But you need to be aware of that. So that you understand what the result needs to be. Because you could do all of this work right, but if you stop here, you didn't answer the question. Okay? You didn't answer the question. All the way there. It's a shame to do all that work and not get full credit because you missed one thing. That should be a 3. I don't know why I changed it to a 2. I was writing fast. Thank you for pointing that out. You hide something. Thank you. All right. Questions on that? You guys having fun yet? I'm having fun. That's great. That's the good stuff. All right. Horizontal line that passes through 4, 5. What type of equations give me horizontal lines? Y equals, right? Horizontal lines are y equals. Well, what does y equal? Done. It's a horizontal line, which means y equals. It passes through the point 4, 5. It also passes through 3, 5, and 5, 5, and 10, 5, and 25, and negative 55. Okay? Y is always 5. Horizontal line. Find the equation of a line containing the point 4, 5 with an undefined slope. What kind of equations have undefined slopes?
0.
X equals. What type of line, other than, so x equals, what does the line of an x equals look like? Vertical. Okay? So vertical line, x equals, well, what does x equal? 4. Boom. Done. X equals 4. Because I had the point 4, 5. I also had the point 4, 4, and 4, 3, and 4, 2, and 4, 1, and 4, 6, and 4, 7. X is always 4. Now the slope is undefined, which would be a number over 0, which is why we get that undefined slope, but the equation is x equals 4. What's the slope of a horizontal line? Okay, vertical lines are undefined, horizontal lines have a slope of 0. Alright, parallel perpendicular, almost done. We got good time. Alright, we did good time this class. Thanks for Alright. Find an equation of a line that contains the point negative 2, 4 and is parallel to this line. Okay, so parallel to this. And then we want to write the equation in standard form. Okay, what do I know about parallel lines? Touch because of what? Because why? Same slope. They never touch because the slope is the same. do not. Go ahead and just run real quick.
Actually,
Parallel lines have the same slope. So what do I need to know about this equation in order to find a line that's parallel to it? Not that they do have to have the same slope, so what do I need from this equation? The slope. I just need the slope from that equation. Okay? All I need to know about this equation is its slope. I need its slope from that equation. It's the only thing I need from that line. Okay? I don't care about anything else. Because I have another line that goes through this point, negative 2, 4, but it has to have the same slope as this one, so I need to know what its slope is. So how do I rewrite it to get its slope? Not point slope form, close. Slope intercept form. Yes. So 3y equals negative x plus 6. Pass the 6 from one side to the other, or the x from one side to the other. Subtract x, and then divide by 3. Y equals negative 1/3 x, and I literally don't care about the rest of it because all I needed is the slope. It's 2, but I don't need it. I don't need the 2. I just need the negative 1/3. That's the only thing about that equation that I care about, is that it has a slope of negative 1/3. The rest of the equation is garbage to me now. Toss it. All right? So I rewrite this equation in slope-intercept form to find the slope, and I don't give a flip about anything else with it. Okay? So now, I have a line that is parallel to this one that passes through this point. So since it's parallel, it has this slope, and it passes through, if I could erase, nope, can't erase apparently. Okay. It passes through the point negative 2, 4. So if I have a slope that's the same, that's negative 1/3, and it passes to the point negative 2, 4, how do I find my equation now? I have a point that has a slope. What do I use? Okay, I've got a point, I've got the slope, point-slope form. Y minus y1 equals mx minus x1. Okay, y stays the same. Y1, what's y1? 4. Y minus 4 equals, what's my slope? Negative 1/3. X minus, what's x1? Negative 2, so I'm going to make this positive 2. Minus negative 2 becomes positive. I just saved myself a step there. Okay? Minus negative 2 becomes plus 2, so I saved myself a step. And now I want standard form. So what's standard form going to look like? What do I need to do to end up with standard form? What's my goal? X and y on the same side. What else? And get rid of my denominators. But my end goal is x and y together, my constants on the other side, and get rid of my denominators. So distribute first. I'm going to move the 4 over. Equal negative 1/3 x. What is that? 3 1/3. So 10/3. Okay. Move the x over now, because I want y and x together. So that ends up with positive 1/3 x plus y. And then how do I get rid of that denominator? By 3. 3 times 1/3, that cancels. Leave me with x. 3 times y gives me 3y. 3 times 10/3 leaves me with 10. There's my parallel line in standard form. Parallel line in standard form. Interesting about parallel lines in standard form. Actually, let me see if you can find it. Oops, meant to use my highlighter. My highlighter. There it is. Here. And here. What do you notice about parallel lines in standard form? And they're going to have different c values, and your coefficients are going to be the same. A and B will be the same. C will be different because you have to have that different intercept, right? So you have to have something that's different. Okay? But to end up with the same slope, your coefficients have to be the same. Because look at how we get our slope. We take the coefficient of x and divide it by the coefficient of y. We take the coefficient of x and divide it by the coefficient of y, and we're going to change the sign because we do move to the other side. But those values have to be the same in order to end up with the same slope. Okay, so same slope, coefficients are the same, but your constant's going to be different. So you end up with a different intercept. Okay? Questions on parallel lines. Okay. What do we know about perpendicular lines?
They cross.
Okay. What else? Opposite reciprocal what? Slope. Opposite reciprocal slope. So again, the only thing that I care about from this equation is its what? Its slope. Okay? So to get that perpendicular line, the only thing I care about is its slope. So, slope intercept form. 2y equals negative 3x plus 7. Y equals negative 3 halves x. And then again, I literally don't care about the rest because the only thing I needed was the slope. I don't care about the rest of the equation. I only need, okay? So if this line has a slope of negative 3 halves, I need to get its opposite reciprocal for the perpendicular line. Okay? So if m is negative 3 halves, what is its opposite?
3 halves.
Positive 3 halves.
Oh,
right?
the reciprocal would be positive 2.
Yep. And then to get the reciprocal, we flip our fraction. So the opposite reciprocal, my new slope is 2/3. So my perpendicular line has a slope of 2/3. My original line has a slope of negative 3 halves. All right. So here's my new slope. Here's my point. I have a point and a slope. What am I going to use?
Point slope form.
Okay. See how there's a lot of similar steps? Okay. Point slope form is going to be a common default to get us whatever else that we want. It's going to show up a lot. Okay. So the point slope form shows up a lot. Slope intercept form, we'll start with from time to time. We end up getting there a lot to get our slope. It just depends, but a lot of steps end up being very, very similar. Okay? Y minus y1 equals mx minus x1. Y plus 5 equals 2/3 x minus 3. Okay? So there's point slope form of my perpendicular line. Point slope form of my perpendicular line. Point slope form of perpendicular line. Now, what form does it want my equation in? What is the question one? Because it says write a function. So what do I have to do to point slope form so that I can get it to function notation?
Change it to fx.
Yep, but before I can change y to fx, what do I need to do? Before I can change y into f of x, y has to be by itself. Get y by itself, which is what form? Y-intercept form, okay? So y plus 5, let's do distributive. That'll be minus 2 when we distribute. Then subtract 5. Y equals 2/3 x minus 7. And then f of x is 2/3 x minus 7. And that's our perpendicular line function notation. Isn't it fun? You're wrong, but it's okay. So I distributed 2/3 times -3. The 3's cancel out, leaving me with just the -2. Yeah, but I still have to have y by itself. And then we have to simplify the equation. So function notation. Function notation is almost identical to slope-intercept form. Okay? Except it's f of x instead. Almost identical to slope-intercept, except it's x instead. So we have to get y by itself, slope-intercept form, replace with f of x. Okay. Any other questions, comments, concerns, queries, or amendments? All right. So this last slide is just kind of a recap of everything that we have. All right. Standard form: ax plus by equals c. It's a linear equation. A and b are both not 0. Okay. Slope intercept: y equals mx plus b. Point slope form: y minus y1 equals m times x minus x1. Horizontal line: slope of 0. Y intercept is given. Y equals c. Vertical line: x is a constant, slope is undefined, and the x-intercept is given. Parallel and perpendicular lines, the difference between those. Okay? You need to know all of these things. Okay? You need to know those formulas, those setups. You're going to be using them. So write them out every time you use it. If you see, oh, I need standard form, write out standard form. If you know that you need slope-intercept form, write out slope-intercept form. If you know you need point-slope form, write out point-slope form, and then start filling stuff in. That's going to help you memorize it. Or don't, and then get confused on your test, and then struggle, and then lose points, and then be sad about it. I mean, you're big boys and girls. Okay? But I'm giving you my best advice, having done this for a while. Okay? So it's there to help you.